This video is about the regio and stereoselectivity of the Diels-Alder reaction. The regioselectivity of the Diels-Alder reaction comes down to where the partially negative or nucleophilic carbon is and where the partially positive or electrophilic carbon is, and these need to align for the reaction to occur. The best way to figure out where the charges lie is by drawing the resonance structures of both your diene and your dienophile. As you will notice, the way we've drawn them, the partial charges are not aligned with each other. So we will have to flip one of the two structures so that the charges are more aligned. At this point, they are aligned to react and the reaction can occur. Now you try with this example. Pause now. And here is the answer. Now just to double check, let's check out the resonance structures and when the partial charges. Right here, which means we need to rotate the dienophile, like here, to give us the product that's shown. As you might have noticed, we are also forming stereocenters during the Diels-Alder reaction, so of course there is stereoselectivity. How does this arise? Well, the reaction itself of the diene and the dienophile is not just planar with them next to each other. In fact, they react on top of each other, or where one is above the other, like in this image. Furthermore, if you have a carbonyl, it will be attracted to double bonds. Why? Because of that partial positive charge on the carbon of the carbonyl. And of course, the double bonds are negative, so you get this attraction between them, which causes them to stack. What this means when you're aligning your structures is not just to align the charges, but you must also, if there is a carbonyl, point it towards the double bonds of the opposing molecule. But what's this got to do with the stereocenters, I hear you say? Well, we then apply this template to get the correct stereochemistry in our product. As long as we align the diene on the left and the dienophile on the right, according to this template, and you make sure that your carbonyls, if you have any, are pointing towards your opposing molecule, you will get the correct stereochemistry and that of the enantiomer by using this template. So applying this template to our previous example will give us the following correct product. Of course, it doesn't seem that important when you only have one stereocenter because both enantiomers are formed. The regioselectivity is king. However, if you have multiple stereocenters, then the stereochemistry becomes very important and you need to make sure that you know which substituents are up and which substituents are down. Here's another example. Pause now. And here's the answer. Finally, just as an additional note, we can also have an alkyne as our dienophile, which will then lead to a cyclohexadiene product as opposed to a cyclohexene product. The stereochemistry at the sp3 carbons still applies. Here's a practice problem. And here is the answer. Here are some more Diels-Alder practice problems. Pause now. And here are the answers.